Standard forms of standard formulas of derivatives we had discussed. The derivative of x to the power n. What was it? Derivative of x to the power n. You know, you haven't at all done this topic. Continuity differentiability have you done? You have done. You know what is meant by differentiable a function, right? So here derivatives is nothing but the differentiation itself, that is differentiability. So if the function is x to the power n, then its derivative is nx to the power n minus 1. Like if you have x cubed, then what will be its derivative?
3x squared.
X squared. Okay. Then derivative of the trigonometric functions. What is derivative of sin x? Sin x derivative is cos x. Then derivative of cos x minus sin x. You can note this down. Then derivative of tan x is 6 square x. Derivative of cot x is minus cosec square x. Derivative of sec x is sec x tan x. And derivative of cosec x, that is minus cosec x cot x. These are some standard formulas. This is like if you have a polynomial x to the power something, this is its derivative, and these are the derivatives of the trigonometric functions. Okay. This we had discussed yesterday, so you just note it down fast. Then derivative of inverse trigonometric functions like sine inverse x. You know what that is? 1 by root of 1 minus x square. Inverse trigonometry, there is a chapter in which we learn sine inverse, cos inverse, all those things. And cos inverse x is minus 1, same thing, but negative sign will be there. Then derivative of tan inverse x. 1 by 1 plus x square, derivative of cot inverse x. That is minus 1 by 1 plus x square. And derivative of sec inverse x. That is 1 by mod x root of x square minus 1. Then derivative of cosec inverse x minus 1 by mod x root of x square minus 1. These are the derivatives of inverse trigonometric functions. Sine inverse, cos inverse derivatives are the same, but sign is different. Like if you have cos inverse, it is minus. So you can say like if you have functions starting with co, here also there is a negative sign for the inverse trigonometric functions. Okay. Then we had discussed derivative of a to the power x. If some function is like this, here x is the variable with respect to which we are differentiating. That is with respect to x, we are finding what is the derivative. So here the derivative is ax ln k. Ln means it is nothing but log to the base e. Exponential e you have heard, base e. Then, so derivative of if it is e to the power x. E is actually a constant. Here a is there, that a is greater than 0. Okay, and e, you know what is the value of e? E is an irrational number and its value is like 2.71 something something. 2.718, like that it continues. It is an irrational number. And what will be its derivative? It is e to the power x itself. Then derivative of log x, ln x. That is log to the base dx. In calculus, wherever you see log like this, it is the same as log to the base e. That is ln x we are writing. Okay. And this is nothing but 1 by x. Log x derivative is 1 by x. And whenever we take the logarithm function, that variable, it should be greater than 0. So here also log a, I have written a greater than 0. So x is greater than 0 because log is only defined for positive numbers. And similarly, if you take log to some other base a and b, then it will be 1 by x ln a. Here also a is greater than 0. A is a constant, but x is not a constant, x is a variable. Variable means that varies. So these are the important formulas of derivatives. Noted. Now there are some rules of differentiation. So first of all, what is the meaning of differentiation? It is the process of finding the derivatives. Finding derivative of a function. So what are the rules of differentiation? So the first rule is, what is the derivative of any constant? It will be 0. That is, if I ask what is the derivative of 5. So 5 is a constant. It is 0. Constant means here whatever we write inside this bracket, it should be a function of x. But here it is not containing x term. That means it is a constant and derivative of constant is 0. If I write what is d by dx of x to the power 5, then here it is a function of x. X is there. So what is the derivative? You remember that formula? Yeah, it is like x to the power n, that first one, where the n is 5, so it is 5x to the power 4. That will be the derivative. So this is the first point. Any constant you take, the derivative is always 0. Then second rule is, if you have derivative, if you want to find derivative of some constant times some function of x. Like for example, what is the derivative of 2 log x? No, it is not 1 by 2. It is not simply 1 by x. Derivative of log x is what? It is 1 by x, right? Now, this is the function of x I'm taking. Let's say f of x. Here are also function of x. Now here there is some constant multiplied with that function. So if it happens like that, you have to take the constant outside. So it will be like 2 times of the derivative of log x. You understood that? When you just take the constant outside, then it will be 2 times of 1 by x. That is 2 by x. Okay. So that will be the rule. So derivative of some constant times function of x. Take the constant outside. So it will be constant times derivative of f of x. If you have d by dx of five cos x, then what will be the answer? 5 into minus sin x. 5, take it outside, then what is the, we have to multiply, right? What is the derivative of cos x minus sin? The derivative of cos x is minus sin x. So the answer will be minus 5 sin x. Okay. You can just note it down, like for this example. So you can just take that constant, whatever it is there, just take it outside and simply differentiate that function. And that we have learned in the standard formulas. What is the derivative? That is clear? And the third rule is, what is the derivative of f of x plus g of x? Let us suppose you have two functions of x and in addition, then what will be its derivative? So its derivative will be, you separately find the derivatives of each function. Okay, derivative of f of x, then derivative of g of x, and then you add them. That will be the derivative of the sum of the functions. Like if I ask you what is derivative of x plus tan x. So here two different functions are there. So what is the derivative of x? Derivative of x is 1. Okay, see d by dx of x. So it will be, it is nothing but x to the power 1, right? Or else you can think like dx by dx. So it is 1. X to the power 1 means if you go by that formula, it will be 1 into x raised to n minus 1. So 1 minus 1. And what is x to the power 0? Any number to the power 0 is 1. Any number to the power 0. That is always 1. Okay. Any number you take, if the power is 0, then the answer is 1. So this is nothing but 1. So, or you remember like dx by dx. So it is 1. Okay. So derivative of x is 1 plus. Now you ask what is the derivative of tan x? Sec square x. So the answer will be 1 plus sec square x. Similarly, if you have subtraction, so you can apply this formula for subtraction also. Then here it will be subtraction. Okay, this we call plus or minus. Like together we can tell. So if I ask what is the derivative of 1 by x minus log x. Try to find this. What is the derivative of 1 by x? How will you find the derivative? 1 minus 1 by x. Derivative of 1 by x, not 1.
Minus x to the power minus 2.
It will be, what is the derivative of 1 by x? So 1 by x, how we should write? It is
minus 1.
x to the power minus 1. Right? Because see, x is coming in the denominator. So here it is power 1. But if you take it to the numerator, means it will be minus 1. And now you put n is equal to minus 1. Then it will be by that formula n x to the power n minus 1. So this is minus 1 x to the power minus 2 or minus 1 by x square. You understood that? And if I give 1 by x square, then it will be x to the power minus 2. Then you have to go, you have to apply that formula. Then you will get the answer to that. So derivative of this is minus 1 by x square. Then here minus is there. So according to the rule, you have to put minus. Then what is the derivative of log x? 1 by x. So this will be the answer there. So I will tell you what pattern you can observe for derivatives like 1 by x, 1 by x square, 1 by x cube type. If you want to note it down, then note it. Done? So easily how can we write the derivative of x to the power something? Suppose you have like x to the power 5. So this power that will be here as a constant. Then you have to write 1 power less. Okay, so 5x to the power 4. So if I ask you what is derivative of x to the power 100, then what will be the answer? 100 x to the power 99. So you understood the pattern, like if you have x to the power something, you write that value as a constant, then x to the power you take 1 power less. But what if you have like 1 by x? So 1 by x means it is like reciprocal. So minus will be there and minus 1 by, here you have to increase 1 power. Here when we write, we decrease the power by 1. There we have to increase the power by 1. If I ask derivative of 1 by x square, then what will happen is, so you have to, here whatever be the power, that you will write here. Like here it is 5 means we write 500 means 100. Here it is 1, we will write 1. Here it is 2, so we will write 2. Then divided by, you have to write 1 power greater. And 1 minus sign will be there always. Because it is reciprocal type. So remember like that. If you have like this, means this in both of them, that power you write as the constant. And x to the power 1 power less you have to keep. And here like it is looking like that 1 by form only, means reciprocal form. Here we have to write 1 power greater and minus sign will be there. So what will be derivative of 1 by x to the power 100?
Minus 100 by x to the power 100
X to the power 100. Both of them from here only, Bangalore. Bihar. Tamil Nadu. So you came today or?
Studying is completed.
Oh, So we have seen when two functions are in sum or difference, we can separately differentiate and then put plus or minus.